Good, boys and girls. Today we're going to be looking at Lesson 5, Solving Problems by Finding Equivalent Ratios. We're going to start by looking at Example 1. A county superintendent of highways is interested in the number of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks at the local Department of Motor Vehicles. Reported in August 5 passenger registered. There were 7 pickup trucks registered. How many of each type of vehicle were registered in the county in the month of August? So that's our big question that we're trying to answer. How many of each vehicle were registered in the county in the month of August? So we're going to use the problem, write different ratios, and describe the meaning of each. So let's start with the basic one. It said for every 5 passenger cars registered, there were 7 pickup trucks. So we're going to do cars to trucks. And we know that was 5 to 7. Now if we do it the other way, trucks to cars, we're going to see it as 7 to 5. So if we add 5 and 7 together, we should get 12. Cars total would be 5 to 12 because there are 12 parts altogether. Trucks to total would be 10 to 12 because again, there are 12 parts altogether. So now question B wants us to make a tape diagram that represents the quantities in the part-to-part ratios that you wrote. So our part-to-part ratio, car, truck, the last two are part to whole because we're looking at one part of the whole. And our trucks. Now we know we have 5 cars and 7 trucks. So when we draw a diagram, make sure we have 5 boxes. One, 2, 3, 4, 5, 6. Draw one more box. We get 7. Good. Now question C wants to know how many equal sized parts does the tape diagram consist of? We're going to figure out how many parts there are. We have 12 parts. So there are 12 parts for question C. And B is asked what quantity do they present? Well, if we go back into our question, it says a total of 192 registrations were purchased for the passengers and pickup trucks during the month. So our total quantity is going to be 192 vehicles. So we have 192 vehicles. Let's go to the next page. So question E wants to know what does each individual part of the tape diagram represent? So if we're looking at our tape diagram, we're trying to figure out what they represent. So we know that there are 12 parts and 192 vehicles. So what we need to do is divide 192 by 12. 12 only fits into 19 once. 1. And subtract 19 minus 12 is going to give us 7. Bring down the 2. 12 goes into 72. So we're going to subtract. And look at that. There's nothing left over. We know that each equal part is going to represent 16. So each individual part is equal to 16. All right, so question F. how many of each type of vehicle were registered in August? So we can figure this out by going back to our tape diagram and filling in that each one of these parts is a value of 16. All right, so if we know each of these parts are a value of 16, then we can do 5 times 16 to figure out how many cars, and 7 times 16 to figure out how many trucks. So let's start with our cars. We're going to do 5 times 16, and when we multiply that, we should get 80. When we do it with our trucks, we're going to do 7, because there are 7 parts, times 16, and we should get 112. So now we can answer our question. There were 80 cars and 112 trucks that were registered in August. Boom, simple. All right, example 2. The superintendent of highways is further interested in the number of commercial vehicles that frequently use the county's highways. He obtains information from the Department of Motor Vehicles for the month of September and finds that for every 14 non-commercial vehicles, there were 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, how many of each type of vehicle frequently use the county's highways during the month of September? So we're going to box in our question. We're going to underline 108 more non-commercial vehicles. All right, so we're going to start with drawing our ratio. So we have non-commercial and commercial. So for non-commercial, we know there are 14, and for commercial, there are 5. So we're going to draw our boxes. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then for our commercial, we're going to draw our 5 pieces for our tape diagram. Oops, made it a little too big. Good. Now we know that there are 108 more non-commercial vehicles than there are commercial vehicles. So we're going to take away our 5 parts out of the top. So 1, 2, 3, 4, 5. We're not going to count those because we know we have 108 more non-commercial than we do commercial. So 108 more. So when we do 14 and we take away those 5 parts, we know this also represents 9 parts. So we've got to figure out how many, or what the value is for each of these parts of non-commercial. So what we're going to do is we're going to start by doing division. So we're going to divide 108 by 9. Now 9 fits into 10 once, and we end up with 9 left over. 9 fits into 18 twice. So we know that our final answer is going to be 12. So each one of these boxes is going to represent 12. All right, now we need to find the total amount for each type of vehicle. So we're going to multiply our 14 by 12 because there are 14 parts of non-commercial and 12 in each part of the tape diagram. So for non-commercial, we're going to do 14 times 12. And when we multiply that, we should get 168. Now let's do commercial. We're going to do our 5 times 12 because there are 5 parts and each part is valued at 12. When we multiply 5 times 12, we should get 60. So now we need to write our statistics in order to get to the quiz. So there were 168 non-commercial and 60 commercial vehicles registered and counted. Now let's go back and make sure we actually answered the question that was asked. So how many of each type of vehicle frequently use the county's highways during the month of September? So there were 168 non-commercial and 60 commercial vehicles registered in September. And we're going to add to that frequently use the highways. Good. Completely answered. We drew our tape diagram. We figured out what each piece was worth. We figured out what the total value was for each part of the tape diagram, and then we answered our question. Let's go on to the next page. So right now we're going to do 4 practice exercises. So the first one says the ratio of the number of people who own a smartphone to the number of people who own a flip phone is 4 to 3. If 500 more people own a smartphone, flip phone, how many people own each type of phone? So let's start by drawing our tape diagram. Let's put our smartphones on the top and our flip phones on the bottom. So we know our ratio is 4 to 3. There are 4 smartphones for every 3 flip phones. So let's draw our tape diagram. We have 4 parts, and for the other one we have 3 parts. All right, and it says if 500 more people own a smartphone than a flip phone, so we know that 500 more people. So this last box represents 500 more people. Well, that makes it pretty easy for us. So that tells us the value of each one of these boxes then is 500. So now we just got to figure out how many people own each type of smartphone, or each type of phone. So we're going to do 500 times 4, and you should get 2,000. And then we're going to do 500 times 3, and you should get 1,500. So now we can answer our question. How many people own each type of phone? So there are 2,000 people who own a smartphone. And 1,500 people who own a flip phone. All right. So we successfully drew our tape diagram, figured out the value of each box, and were able to write a complete sentence answering our question on how many people own each type of smartphone. Sammy and David were selling water bottles to raise money for new football uniforms. Sammy sold 5 water bottles for every 3 water bottles David sold. Together, they sold 160 water bottles. How many did each boy sell? So let's look more at the question 2. So they were selling water bottles to raise money for football uniforms, and Sammy sold 5 water bottles for every 3 that David sold. Together, they sold 160. So we need to find out how many did each boy sell. So let's look at this. So we have Sammy, who sold 5, and David, who sold 3. So Sammy's is 5 to David 3. 1, 2, 3, 4. Now it wants us to figure out how many did each boy sell, and it gave us the total number of water bottles that were sold. Because we're going to add together both pieces so we can find out how many total parts there are. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide 160 by our 8 parts. 8 goes into 16 twice. We can subtract. And because we have a 0 for our final answer, over here we just put a 0. So now we know each one of these boxes is valued at 20. And we can figure out how much Sammy sold and how much David sold. So if Sammy sold 5, we have to do 5 times 20. So Sammy is 5 times 20, which gives us 100. David, we're going to do 3 times 20, which equals 60. Now we're able to answer our question. We know that Sammy sold 100 and David sold 60. So let's read our sentence. Sammy sold 100 water bottles and David sold 60 water bottles. All right, so we're able to figure out the value of each part when given the total amount. Now let's look at question 3. Miss Johnson and Miss Sipple were folding report cards to send home to parents. The ratio of the number of report cards Miss Johnson folded to the number of report cards Miss Sipple folded is 2 to 3. At the end of the day, Miss Johnson and Miss Sipple folded a total of 300 report cards. How many did each person fold? So we know Miss Johnson and Miss Sipple folded at a ratio of 2 to 3. And our final question is asking us how many did each person fold? And give us a total of 300 report cards. So let's start by making our tape diagram. Miss Johnson was 2, and Miss Sipple was 3. So we're going to draw our diagram of 2 to 3. Now we know our total amount is going to be 300 report cards. So we're going to add up how many parts we have and divide 300 by that. So we have 1, 2, 3, 4, 5 parts. So 300 divided by 5. So 5 goes into 30 6 times. Again, 0 is an answer, so 5 times 0 is 0. So each one of these boxes represents 60. Now we can figure out what they were able to fold. So Miss Johnson did 2 times 2 times 60, which is 120. Miss Siebel did 3 times 60, which is 180. So now we can answer our question, how many did each person fold? So Miss Johnson folded 120 report cards, and Miss Sippel folded 180 report cards. All right, now we're on to our last exercise problem. At a country concert, the ratio of the number of boys to the numbers of girls is 2 to 7. If there are 250 more girls than boys, how many boys are at the concert? All right, so let's set up our ratio. Now we have 2 boys for every girl, or every 7 girls. So boys is 2, girls is 7. So we're going to draw our tape diagram. We have 2. And then we're going to draw our tape diagram for 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 parts. If there are 250 more girls, so 250 more girls than boys, how many boys are at the concert? So we're going to take away the 2 that count for the boys. So we're going to exclude those and go to the rest of this and write 250. So the rest of it is 5 parts. See, 1, 2, 3, 4, 5. So we're going to divide 250 by 5 to find out what equal part is equal to. So 5 goes into 25 5 times. And again, we end up with a 0. 5 times 0 is 0. So our answer is 50. So each little box is equal to 50. So now we can figure out how many boys there were at the concert. So if we do 2 times 50, whoops, we end up with 100. So there were 100 boys at the concert. And there you have it. That's lesson 5. Thank you for watching.